Hi guys, this is section 12.10, example 4, the application problem. I've already gone ahead and written the question. A cargo container, a rectangular solid, must have a volume of 480 cubic feet. Use Lagrange multipliers to find the dimensions of minimum cost if the bottom will cost $5 per square foot, while the sides and top will cost $3 per square foot. Okay, so starting out, we know that we have a constraint that the volume must equal 480 square feet, right? Which if we are just gonna imagine our little container here, we know, and this is gonna be X, Y, and Z, then we know that the volume X, Y, Z is going to equal 480. Okay, so this is our constraint. All right, and we are wanting to minimize cost in this problem, so let's set up the equation for cost. So cost is going to equal, so the bottom of the container is going to cost $5 per square foot, like a different material or something. So the bottom is going to be $5 for just the area there. And then the top, on the other hand, is going to cost $3. So that's $3 for the same area going on. And then all four of the sides are going to be $3. And I have a little diagram of this for anyone who wants more explanation as to where that stuff is from. Okay, so simplifying this down, this comes out to 8xy plus 6xz plus 6yz for our cost. Okay, and we're trying to minimize that value of cost. Okay. So we are going to take the gradient of C. Can anyone tell me what it is? I'm so alone here. Okay, so the gradient of C would be 8y plus 6z, right? Because we're taking the partial to x right now, so it'd be 8y plus 6z, ignoring that because it doesn't have an x in it, x plus now partial y, which is 8x plus 6z y, and now partial z plus 6x plus 6yz. Okay, so here we have the gradient of C. Now let's go ahead and take our gradient for G, or our constraint. So let's go ahead and let G of x, y, z equal our constraint. Okay, now we're going to go ahead, since we've defined our equation for G, we're going to go ahead and take the gradient of it. So the gradient of G x, y, z is equal to, first the partial x, so that would be y, z times I hat. Now the partial y, so that'd be x, z. That is not even letters. X, z times j hat. Now the partial z, so x, y times k hat. All right. So go ahead and I'm going to just put lambda values out, multiplying everything by lambda. Okay, not the nicest looking. So now we are going to go ahead, since we know that each of these components are going to be equal to each other. Let me go ahead and actually, this is going to be equal to this. to be equal to this. And this is going to be equal to that. Sure. Okay. Cool. So these things are going to be equal to each other. So we're going to set up our system of equations, which is going to look like, oh, it smells bad in here. That pen's very strong. Okay. X or 8y plus 6z equals lambda yz. So just taking that, setting it equal to that. Okay, now we have 8x plus 6z equals lambda xz, and we have 6x plus 6y equals lambda xy. The last equation is going to be our constraint. So we have x, y, z is equal to 480. I have some scratch work on how to solve out the system of equations. If you would like to see that, the notes will be posted. But for board purposes, I'm just going to go straight to the answer. So once you solve this out, you find that x is equal to y, which is equal to 3/4 z. And from there, we can go ahead and plug these things into our constraint equation and go ahead and solve out that, well, instead of x, y, z, we would get that y times 3, or wait, sorry, times 4/3 y, I should say, 4/3 y equals 480. This gives us that 4/3 y cubed equals 480. Little math there, then y is equal to the cube root of 360. So then from there we can get that our like x and z values from there. So x would be equal to the exact same thing, the cube root of 360. Y, we just have that right there. I'm going to rewrite it. 360 cube root. And then z is going to be equal to 4/3 times the cube root of 360. So in actual like numbers, if I plugged it into my calculator correctly, the box would be approximately 7.11 feet by 7.11 feet by 9.49 feet. So there we have it. We have solved out an application problem.